Here we have another composite function where we need to find f of g and g of x. But if we have a look here, we can see the danger signal. That's one of the worst signs you'll ever see. And the danger signal is there because, as we're hopefully familiar now, we have a square root. And whatever is under the square root, whatever is in here, needs to be greater than or equal to 0. Otherwise, the square root malfunctions. So let's have a look at part A for the question, and we'll see where this plays out. Now, f of g of x, what that means is we need to ensure that we look at g of x first. So f of g of x will equal f of 2x minus 1, which equals, now we're going to substitute 2x minus 1 wherever we see x, root 2x minus 1. Now, remembering that we have a rule here that says the range of g must be a subset of the domain of f, remembering because here we have the g of x machine that has to pump out a number into my f of x machine, and then we get an answer. We need to make sure everything that comes out of here can go in there. Now, if g of x is 2x minus 1, if I have all real numbers going into 2x minus 1, I'm going to get all real numbers coming out of 2x minus 1. This isn't a parabola, there's no restriction here. Which means that if I have real numbers coming out and going into a square root function, it won't work. We also know it won't work because I can't just throw any number in here to make sure I get an outcome. If I put in negative 100, this would be negative 201, we're going to have a problem. So therefore, this function, if it can't do any value, it can't do all values, and therefore f of g of x is not defined. Okay, so we'll say here as the range of g of x is not a subset of the domain of f of x. It means our machine breaks down. F of g of x is not defined. Now what I'm going to do is I'm going to actually skip now to part C, because part C asks for the function that isn't defined, find a restriction that would mean it is defined. So let's have a look at that before we do part B. So part C here, what we'll do is we come out with this function here, where f of g of x is root 2x minus 1. Now we know that what's under here must be greater than or equal to 0, so we can work out our domain and restrict it so that this works, which would mean for it to be defined, or for the function to exist, 2x minus 1, what's under the square root, must be greater than or equal to 0. Therefore, 2x is greater than or equal to 1, and therefore x is greater than or equal to 1/2. So if we restrict the domain, so if x is an element of, remember, square bracket, because we've got an equals to, from 1/2 to infinity, then f of g of x is defined. So now we've worked out the restriction that would allow this composite function to be defined. Now that we've done part A and part C, let's go back to part B. Part B asks us for GOF. So g of f of x. So now let's find out what that equals. That equals g of root x, which equals equals 2 root x minus 1. So there's our function there. Now, we have nowhere in our g of fx machine, so we have nowhere in our f of x machine, any numbers that go into f of x can be put in to g of x. Or if we will, when we have a look at our range of f of x, whatever numbers we put in here, don't worry that we can't put negative numbers in at the very start. That doesn't break the function down. The function only breaks down, or the composite only breaks down, when this middle part here doesn't work. Now, at the moment, whatever number we put into f of x, we're going to end up with the range. Now, we don't have a positive negative, but that doesn't matter. We're going to end up with positive numbers and 0 coming out of f of x. Now, if this is a subset of the numbers that can go in here, and any number, my domain of g, are real. Because this is a subset, these values that come out of f of x are completely contained within all real numbers. This will work, and the function's defined. So we don't have to restrict the domain. So therefore, g of f of x, g of f of x is 2 root x minus 1. Our domain, because of this x, will obviously be 0 and positive numbers. All right? So therefore, my domain I can write here is x, such that x is an element of 0 to infinity. And that's fine. This is defined. The previous example wasn't, because it's the link between the two functions, or even more rules-based, it's the rule of my domain of the outside function needs to be bigger than my range of the inside function. Or better put, the range of this inside function needs to be a subset of or equal to the domain of the bigger function.
If you found this video helpful, please subscribe or like. Thanks.